Hi everybody, in this quick video I just want to summarize and finish the example we did in the live session. So in the live session we fixed a very simple probability space. Omega was the numbers between 1 and 12 and with equal chance each. And then we fixed a random variable on this omega, which was 1 on 1, 2, 3, 4. It was 2 on 5, 6, 7, 8. It was 3 on 9, 10, 11, 12. The sigma algebra generated by this random variable, we found that to be essentially containing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 as interesting sets, and then all the unions and intersections and complements of that. And so these are the elementary sets of interest for this random variable. We were looking at Kolmogorov's theorem on conditional expectations, and this was featured in another video, so I'm just showing it very briefly. Essentially, to find the version of the conditional expectation V, we're just looking at a random variable which is G measurable, it has a finite mean, and it satisfies this expectational identity for all sets G in the sigma algebra script G. Okay, and we aim to find this in our example with this random variable Y. So what we want to do is define another random variable x, which that's what we did in the sample class. So x is very similar to y, except it can take on 6 different values, 1, 2, 3, 4, 5, 6, depending on omega being in 1, 2, or 3, 4, or 5, 6, 7, 8, 9, 10, or 11, 12. So it's very similar to what we had for G, for y, but just a bit finer. So if I put y here, that's what y was, this is what x is. It's almost the same thing, except y only has 3 different values, x will have 6 different values. And so what we started to calculate, or we essentially calculated in one case, is the conditional expectation of this x, which can be anything from 1 through 6, given the sigma algebra G that was generated by y. Okay, so given this sigma algebra, that's what we started to do. And so the first condition said that this thing has to be G measurable, so it has to be a constant on 1, 2, 3, 4, it has to be a constant on 5, 6, 7, 8, it has to be a constant on 9, 10, 11, 12. And then we picked our first interesting set G in script G. So recall that was script G down here. So we took the first interesting set, which is 1, 2, 3, 4. On that set V is a constant, and so calculating the example, we find that on that constant V has to be equal to, if you just write up the two sides of the equation which we did in class, V has to be equal to 3/2. Okay, so on the set 1, 2, 3, 4, V, the conditional expectation is 3/2. What I want to continue with now is to just mention, not do it all the way down, but just to mention that if we pick G equals the next interesting set, which is 5, 6, 7, 8, and do the same calculation. Expectation of our function V on that set equals the expectation of our original random variable x on that set. If we want to do this equation here, on the left hand side, V is a constant again, because V is not allowed to change within 5, 6, 7, 8. So this thing is a constant on that set 5, 6, 7, 8. It's not allowed to change there. So if I multiply this constant with the rest of the expectation, which is just the expectation of the indicator, in other words, the probability that omega is in 5, 6, 7, 8, that's my left hand side. My right hand side has to be equal to the expectation of x on G. So if I bring back what x was, x did this, G is 5, 6, 7, 8 together, so expanding that expectation, x could be 3 with probability of omega equals to 5. It's 3 again when omega is 6. And then it's 4 when omega is 7, and it's 4 when omega is 8. And so on the right hand side I'm getting 3 plus 3 plus 4 plus 4 times 1 over 11 for each of these probabilities. Again, I solve this. This is 4 over 12. This was 1 over 12, not 11. I solve again, and I get 3 plus 3 plus 4 plus 4 over 4, which is what? This is 14 over 4, or 7/2. On this G, on this set 5, 6, 7, 8. Okay? And then finally, so why is it 7/2? 7/2, in other words, is 3.5. And of course, no surprise, 3.5 is just the average of 3 and 4, which covers the set G 5, 6, 7, 8, 5, 6, 7, 8. Okay? And in a very similar way, if I do now the next elementary or simplest case, 9, 10, 11, 12, I'm not going to do the calculation, then V is going to be a constant on there, and V is going to be which constant? Well, if you do the calculation again, it's halfway between 5 and 6, so it's going to be 5.5 or 11/2 on there. So what I find is that V is a random variable. What I find is that V is a random variable. It's a function of omega. Okay? And so if I put together everything I had here, then V is going to be 3/2 on that set. So it is 3/2 on omega equals to the first set, 1, 2, 3, 4. It's going to be 7/2 on omega equals the second set, 5, 6, 7, 8. And it's going to be 11/2 on omega equals the third of these sets, 9, 10, 11, 12. This is what that is, and this is a version, well, this is in this case, this is in this case all of expectation of x given G. And if you watch the video carefully, then you notice that G was the sigma algebra generated by Y, so in fact what we have is that this is actually the expectation of x given Y, and so I can further write this as 3/2, 7/2, or 11/2 on which set? On omega equals 1, 2, 3, 4 means on Y equals to 1. Omega equals 5, 6, 7, 8 means Y equals 2. Omega equals 9, 10, 11, 12 means Y equals 3. So now we can really see that this is a function of Y. If Y is 1, then it's 3/2. If Y is 2, then it's 7/2. If Y is 3, then it's 11/2.